Okay. I wanted to create this today as the first workflow to go through. And with this one, we can see we have control over kind of the density of the pipes. And these are all controlled by a 3D voronoi cell. So we're going to go through this and kind of run through all these different steps here with, again, creating the voronois for the people that weren't here last time. And then we'll walk through finding mesh intersections, using a random number generator a little bit to get some randomness into the script, using one of the new components called the shortest walk, which I'll explain what that does in a second. Dynamically moving curves based on some attractor points, kind of similar to what we did last time, using some other plugins, Dendro and Pufferfish, for doing some Boolean union operations without using the Boolean union in Grasshopper, because it's not that stable. And then adding colors to meshes and looking at how to export colors and stuff like that. So everyone should have the file that I sent. It was a Grasshopper file. It just has one mesh component in it, and that's going to be the base mesh for this person that we'll use to create this script around. So if you want to pull that up, we'll get started using that. Okay, and everyone on Zoom can see the screen of Rhino, correct?
Yeah.
Cool, sounds good. Okay, so everyone should have that file open. Let me know if you don't or if it's not working. I don't know what Susan's doing, but yeah, so did you download the Grasshopper file that I sent in the Discord? Okay, yeah, so if you have Grasshopper open in Rhino, you should just be able to go to File, Open, and then it's called Base Human Form is the file name. Yeah.
I didn't have my Rhino window next to me. I just see the mesh and I'm like, what's going on?
Oh, yeah.
I just see one component.
Did it? Yep. Yeah, we'll build everything else around that component, but it's a good starting base for everyone. Oh, yes, Sarah, I can email that to you. Okay, that should be coming in a few seconds, Sarah.
Which one was the?
It's called Base Human Form. It should be in file sharing in the Discord. Yep. Okay, so I believe everyone's good, so we can get started with this. Okay, so everyone should have this form in the middle. Let me pull up bifocals as well so we can see everything. Yeah, right now I'm going to keep it on the preview everything mode so you can all follow along. Okay, so if you saw what we were doing earlier, we had those mesh pipes going around the form to create like a outfit or something of the sort. So to get to that, first thing we have to do is make a pattern just around the form that we can then base those lines off of. So going off of what we did last class with the 3D voronoi, we're going to do a very similar thing and base a 3D voronoi around this form. We can use the we could use the entire body, or you could cull out just a section of it. But right now we're going to keep it simple and just use the mesh that was given to us. So with the voronois, just like last time, the first thing we can do is bring up a voronoi component. And just like last time, there's two of them. There's a 2D voronoi and a 3D voronoi. In this case, we want to go with the 3D voronoi because we have a 3D shape. So we'll bring that into the scene. With the 3D voronoi, you'll notice if you haven't used Grasshopper much before, the components have inputs and outputs. If you hover over any of the inputs, like the P, it'll give us a little description of what it wants. If we hover over the output, it also gives us a description. And if we hover over the image itself, it gives us a description of the component and what it does. So we'll see with this voronoi component, this is the one that's going to make our pattern. What it needs is a list of points and a boundary region to define the pattern within. So the first thing that we can do is create that list of points to create this pattern. So super simple. We're going to make it easy on ourselves, and instead of slowing down all your computers by generating cells for the entire form with just a scattering of 3D points, we can put those points right on the surface, and that'll keep down the number of operations that your computer will have to do. So with creating a cloud of points, there's 3 different options, and they start with the word populate. So we have populate 2D, 3D, and geometry. I believe last class we used 2D and 3D, and those are just for simple regions. So today we'll go with populate geometry, and this will work with any vrep or mesh or surface that you have in Grasshopper. In this case, we have a mesh that I gave to you all, and if we hover over the little mesh icon, we can see that it's defining a mesh there with the vertices and faces. So with this one, what it needs is the geometry, which we have, which is the mesh of the human. It also has a count for the number of points that we'll be populating onto the mesh, and then a seed for randomization and an input list, which doesn't matter for this. The main 2 things, though, are the geometry and the number of points. You can see with the number of points, it comes pre-filled with 100. So if we plug in the mesh there and click on this component, we can see it populating in Rhino that we have 100 points now localized on the mesh object. So that should be pretty straightforward. Nothing bad should be happening yet. Right now it's at 100, so that's not a lot of computation on your system. But if you start moving up like past 1,000 points or something, it might get a lot slower. So keep that in mind, but we won't be going that high today. We can set up a slider though to change these points if we want to change them later on. With Grasshopper, as I've explained in the past classes, we have a lot of control over the final output of the script with some basic inputs on the front end. So if we change a basic input, it'll affect the entire workflow and give you a completely different output down the line, which is a really powerful tool, an opportunity that Grasshopper gives us. So we'll put a number input here for the number of points. And the easiest way and the most interactive way to do that is with the number slider, which we've been using a lot, but for the people that are new today, a number slider, you can basically slide and get different numbers in there. To create it, I'll just we're starting at 100 and we might want to go higher. We might want to add more points. So I'll start with 100 and maybe go up to 500. I don't want to go too high. That's 5,000. So with a number slider, you can put 2 periods in between to give the bounds of 100 to 500. You could put a less than sign. That'll also show a difference in bounds. But if we hit enter here, we should have this slider that comes up and it'll start at the lowest bound, which is 100. If we slide this, you'll see it'll go up to 500 and we can pick any number in between. So with this number slider, we can plug this into the number here. And then when sliding, if we have selected populate, we can see that the green dots will start to multiply as we turn this slider up and down. So this is our first interactive input for the script. On my screen as well, it's showing me how long it's taking to calculate this. Yours might not be. I doubt it is unless you've enabled that. It's not an important thing. It's not going to affect it. But if you want to see how long your components are taking, if there's one that's like bogging down your script and taking a lot of time, we can see that with the profiler button here under display widgets profiler, and that'll just show us how much time it takes for a component to work. So that's what that is. Okay, so if everyone has the points in the scene, that's the first step. Next step is just to plug that into the point input for the voronoi. And you can see when we do that, it's going to automatically create this kind of region around the mesh. And then it's going to create a cell for every single point in the scene. So there's this point here and it has this cell around it, and that's bounded up against this other cell created by this point. So that's how it's all defined. And you'll notice for the boundary region, we didn't define anything. That's because it is optional for this, as it says. It'll just create a boundary based on where all the points are in the scene. So it'll try to draw a box, the best fit box around all those points. We could define our own region, but for this case, it doesn't matter because we're not going to go any bigger or smaller than the input that we have here. Okay, so now that we have this voronoi around the mesh, the next thing we are going to want to do is find the intersection between the cells of the voronoi and the base human mesh that we have. And the reason for finding these boundaries is because the pattern that we want to create is going to be kind of locked to the outline of the mesh. So if we use this, there's points like up here that are way far off the mesh. And for this case, for having like a garment type thing made, it's not going to make much sense if the garment is very far off the body. So we'll use a couple components here to find that intersection between this pattern and the mesh underneath it. So in order to find the intersection, there's this command, which is also, I believe, under intersection tab, which is the X up there. But it's also called the mesh intersection. So it'll find the intersection curves between two meshes. So you could type in mesh intersection, or you could type the abbreviation, which is MMX, and we'll have this component here, which will find an intersection curve between two meshes. So that is also under intersection physical. And then we have these options here. There's also one for if you had two B reps. As I've been reiterating in the class, the data types matter a lot in Grasshopper. If you have a B rep, that's not a mesh, and you can't go between the two. A mesh has to be a mesh, and so forth. So we'll use the mesh here. And that's just because we're starting with the mesh as the base, and converting this to a B rep is more challenging than just using a simple workflow such as this. So with this mesh intersection, it's asking for two meshes to find the intersection in between, clearly. So the first thing we have is the input mesh, which we can add to one of these components. But you'll notice for the other one, whether that be A or B, all the cells that we have here and the cells, this is not part of the workflow, but just to show that this is a single cell out of this system. So each of these cells, if we hover over the output, says it's a B rep, which is not a mesh. So it's not going to go well into the mesh intersection. So we have 100 of those cells here. So in order to convert them into a mesh, we can go from B rep to mesh quite easily. Going the other way around is a lot heavier and not the best way to do things. So super easy though to convert this to basically triangulate the B rep to have a mesh body. So what we can do is there's a component called mesh B rep, and this will just convert simply a B rep into a mesh. So with this, we'll be able to solve for the issue of not having mesh here and converting those cells. So coming from C into the B rep input for the mesh B rep, that'll convert them all to meshes. Visually, this won't change anything, but as far as data types go, now we do have meshes, as before we only had B reps. So using this, we've solved for all the inputs, and we can plug that into A with the input mesh being into B, or vice versa. It does not matter for this component.
What's the component up in the top right?
like this one? Or-
List item.
Oh, list item, yeah. Yeah, this one's not important for the workflow, but what this one does is it'll take, if we see with the cells here, we have a list of 269 cells because I have an input of 269 points here. So we have the same number of cells. The list item, all this is doing is we can put an index in here. Currently it's 0. So this will just take the first item of the list and show it to us.
Okay.
Yeah, I could change this to from the first one to the second one, and this will give me a different cell, which is down there. So this is just pulling out a single item from that large list that we have here. Okay, so now we should have this intersection, so it'll kind of look like a wireframe of the input mesh with this final component. For most of your screens, I'm assuming it probably looks like this, so we have a lot of stuff going on right now. So the Rhino scene's a little messy. We can't really see what we just did. So there's two ways to solve for this. The first would be to do what I was doing, and there's this little green cylinder up here. If we click this, I forget what it's called, it's not telling me, but what this will do is it'll turn off everything except for the component you have selected. So this may be nice if you're working with a lot of things and kind of want to pick and choose at which step you want to view the progress. If we turn it off, it'll go back to showing everything. The second way we can solve this is to select everything we don't want to see in the scene. And if we right click off to the side of the canvas, it'll give us this large menu for everything, and we could preview it all off. You can also preview on and off individual components if you just click on them. But if you want to do a large group, if you go off to the side, you can change the preview settings there. So I'll just continue like this, previewing off everything I don't want to see. Okay, so now that we have the intersections, I just want to show quickly what the shortest walk component does in terms of Grasshopper. So we can see here, this is a kind of a very simple workflow of what we'll be doing today. But basically, what the shortest walk will do is it'll take a grid of lines. In this case, we have the voronoi diagram from last class. And if we can see that here, which is the pattern, we can put an input curve into the shortest walk, say this line right here. And what shortest walk will do is it'll find the best route between the start and the end of this curve. So what this one is doing is with this curve here, it'll find the best fit line, which is a screen line between the start and the end, and keeping that within the grid that we gave it. So that's the voronoi grid. So you could use this, you know, if you were doing city planning or finding a best route between two lines. This is just a 2D representation, kind of with a city grid right here. And we can see the green path is one line, which is kind of this line I put in, and then the white line is this other line I put in. So we found two best paths there. And I'll share all these later if you want this 2D one, but for today we're working with a 3D version of that. So everything still tracks the same. We have the base curves, just in this case, it's a 3D representation based on that input mesh. So we have all of those curves, or you could say the streets, and now we can find the shortest walk in between a couple of different points. And since we're doing a workflow that requires a random number generator, we can use that to create a bunch of random lines on this, on the base kind of streets here, and then find a lot of the shortest walks in between. And then going from there, we can build up the final kind of garment fit to the original human. So that was probably a lot, but we'll break it down a little bit more here and show how this is all built out. So with these intersection curves, the first thing that the shortest walk component will want, and everyone should have it, it just looks like this black grid with a red line through it. and this is the shortest walk component. So this is the first plugin, the new plugin that we'll be looking at today. Let me know if anyone doesn't have this. This is okay.
Is that in the Discord?
Yep. So we went over this at the end of last class. There's just this one. It's a single Grasshopper component when you download it. So it should be super simple to install. But yeah, if you don't have these two as well, I posted this after at the very end of last class. So Dendro and shortest walk, but these will both come into play in this workflow.
They have to close Rhino again to get that plugin.
Yeah, if you just downloaded it, you'll have to restart it. So make sure you save Grasshopper.
Oh, it's still actually as well in the use or it's in my components folder.
Mhm.
And I think I did that before I restarted it. It's still not showing.
Did you unblock it before you added it to your components folder?
No, no, no.
That's usually the case. Yeah, if you right click on it in the components folder, you should still be able to fix that.
Because it wasn't a zip file.
Right, yeah, you'll still have to unblock it even if it's not a zip file. So any file you download will have to be unblocked. Okay, so is everyone restarting Grasshopper? Yeah. Okay, Soren, were you able to get it to work?
I'm working on it.
Okay,
Yep, I got it.
cool. Okay, yeah, so we can continue if everyone's good.
Thank you.
Okay, so yeah, going back to this with the shortest walk component, the two important things with this plugin are the curves as the list, and then the last one here, which is the wanted path. So what this is asking for is the curves as the list is kind of the base grid that we have. And then the wanted paths is going to be the lines from the start of the trip to the end of the trip. And then what the component will do is take those two inputs and using the start and the end, it'll find the shortest path within the grid between those 2 points. So we have that base grid, and the next thing we'll want to do to solve for both of these inputs is also create the wanted paths so we can get that cool texture that I showed at the beginning of the workflow. So with the mesh intersection, right now, from knowing the plugin, it's going to give us an error if we just plug in this base grid into what it's asking for. And that's because it's not going to find what looks like the shortest path, because a lot of these lines, because of the way we made this grid, could be joined together and there could be really long lines. So in order to foresee that coming and fix that, there is a component in the curve section called the explode component. And this will just take any curve and cut it into line-like segments. So just a bunch of tiny lines if there's a kink in the curve itself. So the input curve group here is going to want just lines. So in order to solve for that, we'll take these curves from the intersection and we'll plug them into the C here. But before doing that, we'll also want to make sure to flatten this output. And if you remember from previous classes, looking at the X here in yours as well, it probably shows a lot of different branches. And that's just because each cell from the voronoi was separate. And when we found the intersection, we're going to have a curve on the mesh for each of those cells, creating a lot of different branches. So by flattening that, we get a lot simpler list here. So all of these curves are within the same list. Just going to go a little bit lower here because these are taking a while. Okay, so if we flattened it, we can plug in the curves from this output into the curves from the explode. And we'll see it'll bring up all of the vertices where the kinks were in the line. And it will have created a new line-like segment in between each of those points that it found. So we should be getting an output looking like this. So with this, we won't need the vertices for the input curve group. We'll just need the segments for that. We'll use the vertices for a different thing. But right now for the segments, if we hover over again, the segment output, we'll also be seeing these are again in branches because now it took each curve and made segments within it. So we're getting branches again. So we'll want to flatten the segments as well as the vertices just to keep this all consistent. So again, going into the shortest walk, we don't want to have a lot of branches of data. We want to have one single list so it can cleanly search everything instead of only searching sections. So with these segments, I foresee an issue coming up where the cells that we found the intersection, such as this one cell here, and then there's a cell next to it, the line in between them, this one right here, these segments, there's probably two segments overlapping, one segment from this boundary curve and another segment from this boundary curve. So there's probably multiple lines in all of these overlapping segments. So one way to solve for that is quite simple with the Kangaroo plugin, which everyone, again, should have from the downloads. Or you probably have it if you have a recent version of Rhino 6 or 7. So I'll just pull it out here so we can see it. So within Kangaroo, under the utility section, there's a really nice component here that removes any duplicate lines in a list. So since we exploded the curves into line segments, we can use this because this only takes lines as an input to find any duplicate lines and just delete them from the scene. So visually, this isn't going to change anything, but if we plug in the segments from the explode into the remove duplicate, we'll see a change in the way the data looks now. So coming from the explode, when you hover over it, in my case, I have just about 10,000 lines. After removing any duplicates, I now have around 5,700. So there was a lot of lines that were overlapping each other. This component was able to clean up that list and take out anything that could cause us issues. So now we should have a lot cleaner list of lines here. Another thing I'll do, just in case anyone has lines that are infinitely small, or any null lines in the list, because this might happen, working like this with finding intersections in a mesh that's not standard. It's not a sphere or something, it's more complex than that, is we can clean up the list coming out of the remove duplicate lines. Everyone should have the next component because it's under the list section, I believe. Yeah, so in tree, under, what is this? Sets tree, there's a component here called clean tree. And if we pull this one out, we can see what this one is doing. So unlike a lot of other components, the main input for any data is coming into the bottom here. So this is asking for the tree that we want to clean up. And then above it are all the settings for how we want to clean it. We can remove nulls. So if there's something that does not exist in the list, it'll clean that up and take it out. If there's anything invalid, like an invalid mesh, it'll take that out. And if there's any empty groups, so if there's a branch that has nothing in it, it'll also take it out. In our case, if we hover over the queue here, we have no branches. All the data is in a single list. And we can see that because it's telling us how many items, and we can see the name of the items as well, all the lines there. So the E comes in false by default, but if you want to remove it, you can just set the Boolean to true. Or you can also grab a Boolean toggle and set that to true as well. But it shouldn't affect the workflow right now. What we want to do though is plug in the duplicate lines into the tree here, and this will clean up the tree and just take out anything that could be making a bad time. It might not change anything, but it's always good to have just in case the data is not super clean. So after doing that, we should still have a list with no branches in it. So clean one branch list. We can plug this final output into the C here, and this is the list of curves that it will be searching later on to find the best path through them. So this is kind of the main roadmap, and the next thing we'll do, the next part of this workflow, is creating the journeys in between points on this roadmap that we have. Okay, so once we have that, the shortest walk shouldn't be doing anything yet. We'll have to create those paths that we want to search in between. So if we come back to the explode, we'll use the vertices of the explode this time. And again, they should be flattened. So we're continuing the same data structure down the line. Since we flatten the segments, we'll also want to flatten the vertices because they'll both be going to the same location, the shortest walk component in the end. So with this component, and I'm going to bring this out just to have it visualize on the screen, but we can see all these vertices here in our roadmap of curves. So in order to find some kind of randomized journeys in between points, what we can do is remove or select either one, a couple of the points, and then we can create lines between those points to construct the paths. So a cool component for doing this, kind of working with sets of points, is there's a component called random reduce. And what this will do is it'll remove a certain number of items in a list. So if we have these, I think it was like 5,000 points, we can reduce out, say, 4,500, and then we can be left with 500 points randomly distributed on this curve system. In this case, we can't really use the populate component or one of these for this, because we want these vertices to be on the curve system itself. If they're off it, it's going to mess up the shortest walk. So we want to make sure we're using the same points that make up the roadmap of curves beneath. So taking the vertices, the random reduce asks for a list to reduce. That'll be the L. So if we plug the vertices into that list, this will be the data that we're seeing that we're going to end up reducing. So in order to actually reduce, we'll have to put a number in here of how many items to reduce from the whole set. We could make it hard on ourselves and go over here and count. There's 10,000 points, and we could type in a number here, say 900, and it would work. But in order to do this in a more kind of intelligent way, we can ask Grasshopper to find out how many points are in the set, and then we can do a simple subtraction to remove just a couple points from that list. So we've used this component before. It's the list length component, and what this one does is it'll find the length of the list itself. So if we're looking at V here, we'll see that it tells us we have 10,209 points, but we can't actually use that value. This output is just giving us the vertices themselves. If we want that actual 10,000 number value, we can use list length, and plugging in the vertices into there, it'll do the count for us and tell us as an output, this is the number of how many points you have. So this is super helpful. We can use this with a tiny little math equation to remove maybe like 20 points less than this entire list. So we're just left with 20 points. So super simple doing that. We can just subtract out, say 20 points. So I'm using this subtraction component. And we can take the 10,000 number and say 10,000 minus 20 will leave us with 19,980. So we can make another slider here. It can be however high you want. You could do 20, or you could go super high and do 200 or something like that. So I'll just start with that range. So I'm just going to do 20 to 200. So when constructing a number slider, 20 ... the upper bounds. Hit enter and we'll get a slider right there. So we can plug that into B. It'll do the math for us, and we're left with a number here. So with that output, we can plug that into the number of items to reduce, or the reduction input. And you can see now, if you've previewed off everything else before this, as I've been doing, as I've been working along, we'll see that we just have those random 20 points scattered within this curve system. So with this, we can connect every 2 points with a line, and that'll be the journey that we want to take between those two lines, and then the shortest walk, we'll calculate that and find that journey for us. So in doing this, what we can do is we'll be creating a line. So I have this component here that creates a line between 2 points. So this is what we'll use to, say, draw a line from this point to this point, or this point to this point. It'll be quite random because we have this random reduce here, but this is the component we'll use for that. You'll notice it has an A and a B, so it needs a start point and an end point to create that line. Now, if we look at the list coming out of here, and I'll pull up a panel as well, just to show it a little bit better on the screen for everyone, is you'll notice we have this list of just 20 points from 0 to 19. These are all on the same list, and it's not really giving us a start and an end point, which is what we want to figure out. So what we could do is we could say that we want to draw a line between 0 and 1, draw another line between 2 and 3, another between 4 and 5, so on until we get to the last number in the list. In order to do that, we could break up this list by every 2 indexes. So we could break up the list saying 0 and 1 goes into its own branch, 2 and 3 goes into its own branch, and so on. In order to do that, there's a lot of components here that deal with moving, inserting, deleting items from a list, which is all these components right here. And for our case, we can use partition list. And this will partition or divide up a list into sublists or branches in the tree. So with this partition list, we can make it do what I just said we want to do. We want to have a branch with only 2 items in it. We can see in the S here, this is telling us the size of the partition. By default, it comes with 3 and 2. So it would be creating a branch with 3 inputs and then 2 inputs and then 3, and just repeating until it runs out. In our case, a line is only made up of 2 points. So I'll grab a panel here. You could also do a number slider, but we don't want to change this value. So I'm just going to use a panel, and that panel will have the number 2 in it. So each branch in our tree will only have 2 items in it, the start and the end point of that line. So plugging the 2 in and plugging the list in, if we compare the output of the random reduce to the output of the partition list, we'll see that we started with a list of 20 points, and now we're ending up with 10 branches that each have 2 points in them. So now we do have a start and an end point for that line. You'll also notice the line here connecting it is dotted, indicating to us that we have a grafted tree or a tree with multiple branches in it. So now we have those branches with 2 points, but you see we only have 1 output still, and we need an A and a B. So we'll use one more component from the list modifiers here, which is the list item, which I used earlier on just to show something, but now we're actually using it within the script. So what the list item will do, as I explained earlier, is it'll pull out a single item from a list. So what we could do is pull out index 0, and we could also pull out index 1. So we have those 2 points. And then we could plug those into A and B. So with the list item, what you could do is you could have 2 of these. This one pulls out index 0 and this one pulls out index 1. And we could use those to create a line. But Grasshopper already thought of this. And instead of doing it like that, if you zoom in far enough into the canvas, you'll see that this list item component, and this is only certain components, but this one has a plus button here. If we hit the plus button, it'll add another output. So now what this one is doing is it'll give us the item at the index 0, and then the item at the index +1 from that. So it'll give us 0 and 1, which if we look at this list is what we need. We need 0 and 1. So we can delete this second one. It's not going to do anything anymore for us. And what we can do is plug this partition list into the list item. And if we visualize this here, we'll see that the thing coming out of the first output is 4.4, which is, yeah.
When you opened up the 2,
Oh, the second one right here.
The partition list.
Yeah, so is it fine if I just leave it like this on the screen, or do you want me to explain it again? Yeah, so
I don't understand where you've got all of the.
oh yeah, so these panels are just for me to show, but if you are searching like for any component, if you just do 2 forward slashes, it'll give you a panel. And if you hit enter, it'll bring up the yellow little window here. And these, they're not used for the script per se, like they're not going to be used later on down the line. What they're kind of used for is for us to see what's happening in this component. So if we just hover over C here, it's not really showing us any of the data. We just see that we have branches from 0 to 9, so 10 branches. And each branch has 2 items in it, n equals 2. That doesn't tell us a lot though. So if we have a panel, we can plug the output into the panel and we can see that we still have branches 0 to 9, but now we can see that these are the 2 pieces of data inside that branch and so on. So it's just a nice way to visualize the data within some of the components, just so you can see what's happening. And right now I'm using it to just compare what we've been doing. So with the random reduce, we have a long list, and all the points are in the same list. When we partitioned it, we broke it up into pairs of 2, so we can plug that into a line for the start and the end points. And then coming out of that with the list item, this was able to grab the actual first point, so the start point for the line. And then with the +1 here, this will be the end point of the line. I'll keep this up. And then just to show, like, this one is the first point here, this +4. And we can see that that corresponds to this one. And then this one, the second, or the end point is this -4. And then that's corresponding to this -4 here. So we can see that it's taken the branches and broken them up into start and end, because we need A and B to construct the line itself. So if we go ahead and plug the outputs from the list item into the line, A and B, we'll see in Rhino that we now have 10 different lines, in my case, 10 lines, and they have a start and an end point, and they kind of show up. They'll probably be different for you. They'll be in a random order in Rhino. Question? What does the error say if you click on the little bubble?
The sum total of all partition sizes must be larger than the zero data conversion scale on price data.
Okay.
I'll come look at it, but. So. And then the bubble was saying that they're. Yeah. Just select everything. And then press OK. So I assume what you did is you typed 2 and then you hit enter. And then that's giving you a 2 and the nothing here below it. And then you were basically telling the permission list to have a list of 2 and then have a list of nothing in it with general arrows. So that's just a quirk with the panel. You have to physically hit OK. Hitting enter will just make a new line. Nice. Yep.
Real quick question, what's that 2 doing plugged into the
This one?
partition list? Yeah.
Yeah, so that's telling the partition list that we want a list with only 2 values in it. If I was to change this, say to 3, you'll see the list now has 3 items in it. Each one is 3. If we had 3 and then 2, another quirk, we have to turn on multi-line data. Then you'll see we have 3 items and then 2 items and then 3 and then 2. So I'll just keep this at 2 for the line, but that's basically what it's doing, was breaking it up into little groups of 2.
What's the search to get that box?
The little panel, yeah. So if you just do 2 // you can get a panel. You could also use a number slider. Like if you just type in the number 2 into the search box and hit enter, you'll get a number slider at 2. That's kind of the easiest way, just to type in a number and hit enter. Which is totally fine. Just in this case, I'm never going to change that number 2 because I don't want a different size of groups. So I just use a panel because it's harder to change than a slider. Yeah. Okay. Yeah, so we don't need any of those panels for the workflow. But I believe I've explained it through, so I just went ahead and deleted them out. So we just have the things we need in the scene now. But everyone should be having these lines connecting 2 points together. Yeah. Okay, so now that we have that, this is all we need for the shortest walk, but you will see if we start to drag this line out, we get a dotted line, which means that they're in a multitude of branches within a tree. Which when we're using Grasshopper, we always want to make sure that the data streams are lined up. So this data stream coming in is a flattened list, so all of the items are in a single list. This one, because we have a dotted line, we can see that they're in different branches in the list. So these two data types are not compatible. They could be, but not for this specific component. So I'll just want to flatten. So if we right click on the output from the line, we can flatten this list, and then everything will be in a single branch, just like the other input for the shortest walk. So I'll just hit flatten. And now if we pull out a panel, we'll see that all the lines are within the same branch. So that looks a lot better. So in doing that, now we can plug in that value to P. And then we should be seeing on the kind of the base roadmap of the lines, we should be seeing some new lines being drawn, connecting those start and end points. Your component is probably going to be yellow. If it's not, you got really lucky. But the only reason this is yellow is because we have some paths here. Try to find one. Like this one to this one, which you see we have this little break between the lines right here. So it can't find a path if there's no way to get there. So it's just giving us a little arrow saying, are you sure the endpoints line up? Which they don't for this path because it can't physically get there. So it's good it doesn't completely fail. It's just telling us that some of the paths are impossible to complete. But I just have a really low count of paths. I only have 10 right now. So we just have a couple of these lines coming through. If we were to turn up that number, you can see we have a lot more paths being found and lines being created. Another thing too is since the partition list can only be the size of 2, you can't have a line with 1 point in it. With this slider here, there is the chance that I could get to a number like 129 that's not even, and then we're just going to have a stray point somewhere. This isn't technically an issue for this workflow because it's still solving it, but I did want to point out one possibility with sliders that you can do. They're pretty smart and have a lot of values you can change on how the slider behaves. And all of those exist if we right click on the slider in the edit panel. We have a lot of options here on what the slider is doing. In our case right now, since I did just 20 to 200, all those numbers in between are integers. We could make it rational, so we have decimal places now. But in our case, this still isn't fixing the issue. We can't have a decimal number of points. So I'll keep them as integers. But we also have these other two options, even and odd here. So we can tell the slider to only stay on even numbers or only stay on odd numbers. In our case, if we only stay on even numbers, then we'll never have the issue that we're trying to make a line with 1 point. We'll always stick on 128 or 130 or 132. So that's just a tip for things you can do with sliders. But I believe that's only possible when you create a slider and then edit it. It's not really possible when you're just searching for it on the canvas. Okay, so at this point we have this, yeah, question? It's completely red. And you flatten the lines going in. Okay. Let me take a look at it.
And the clean list. The clean tree right above it. It's the base. This can happen sometimes, like, but usually happens if we're using vertices that are not on the main curve system. If you back up a little bit. Vertices. One thing I might try is if you're still in Kangaroo, is up in the utility section here, there's another under funds. So if we use this and plug the vertices into this component, and then plug the output into the rest of it, so we do that little data and this one. Yeah, try that just to see if we get any like. But I'll have to plug it into the other one, so all the vertices are. There's a list like probably change that. Some pretty probably fold a lot of them. So if you also plug in the list one. Yeah, just so I'm talking system. Can you make your slider even? So we get a. You could try to do that, do some more changes. You could just maybe like at that number, it doesn't work. Okay, yeah, weird, so. I guess there is a possibility that it could completely fail, but,
Yeah, if we're doing like a simpler workflow, like that little road one I showed at the beginning, you don't really get issues like that. But since we have a lot of stuff moving, a lot of moving parts right now. But yeah, I'm glad it works. Okay. Okay, so now that we have this curve system, we'll be able to move into some of the other plugins that we downloaded. So Dendro and I believe Weaverbird and Pufferfish can come into play now. So now that we have this system, what we can do is thicken it with some air quotes like pipes. So not the traditional pipes from Grasshopper, but we'll be able to construct pipes with Dendro. And then we'll look at symmetry in design, and then also colors on a mesh. So the next thing we'll do, just to make these curves, before getting to what I just talked about, make these curves a little bit more smooth, so they're not jaggedly bouncing back and forth, as we have a couple utilities in the curve section to kind of clean up how these curves look. It's kind of up to you how you want them to look, but I'll show a method for smoothing a curve system out, so the transitions are a little bit cleaner. The first thing we can use here, so the main one is smoothing a polyline, and what this will do is it'll take those jagged edges and kind of clean up the jaggedness and make it flow a little bit nicer.
Quick question.
Yeah.
So is it normal if I just have like a ton of straight lines? Instead of.
I mean, there could be the,
And then like something full.
yeah, I mean,
Instead
there
of
could be
really-
the possibility that your voronoi system had a long straight line, but it doesn't seem like
It's
most
just,
obvious case. I mean, you also have the line being previewed in Grasshopper. So I wonder if you turn that off.
Oh.
Yeah, okay,
A little bit.
cool. Yeah, there shouldn't be many super long straight lines in this, but okay, so coming back, yeah, to smoothing them out. So we have the smooth polyline component, which is really helpful for kind of ironing out some of the kinks in the lines. And looking at the shortest walk, the output here, we have a lot of polyline curves. There's also some nulls, which we could clean up, but shouldn't cause an issue right now. So we'll notice it's giving us polyline curves, and this will smooth out a polyline. But let me see what happened. Yeah, before getting there, this doesn't do much to yet because of the amount of points that are within these lines. If we look back to this one, it's pretty dense in points. So the smoothing has very little effect because of just the sheer number of points here. So to fix that, something we can do under the utility section is reduce the least significant vertices. So these might be vertices that are like 3 of them really close together and they form a straight line. They're not really doing anything to affect the curvature. So we can just take those completely out. And you can see that just plugging it in, it has removed some vertices, but it might have removed too much because now each line is made up of just a couple segments. And we can see that's very, very jagged here. So to fix this, we have this tolerance input. Right now it's set at 1. So this is a pretty high deviation between the original curve and the one we're now getting. We can do a lot smaller number, around like 0.1 or so. I'll use a slider in this case. That's pretty low. So you could do 0.1 to 1. And then if we plug that slider into the tolerance, we can slide between a super small number and a lot bigger number and see how that line changes as we're deviating more or deviating a lot less. The closer we get to 0, the closer it'll look to the original line. And the more we move up, the more vertices we'll be removing. So you can put this wherever. I'm going to leave it at 0.2. It's removed some of the problematic vertices in my case. So once we remove some vertices going into the smooth polyline now, we can see that the lines are actually a little bit smoother than just having the shortest walk itself. This didn't really do much after removing the least significant vertices. We have a lot more smoothing going on here. You can also change the amount of smoothing if you want to add a value to the strength. By default, it comes in at maximum strength. I'm just going to leave it like that. So it has a value of 1 in the maximum strength. So now that we have those curves, if we consider the original mesh that we had started with in this workflow, all these lines that we created are pretty closely intersecting the mesh itself. So if we were to add a pipe to these lines, basically add thickness to the line, it'll be intersecting the mesh that we had to begin with. And in this case, if we want to wrap this structure around the original mesh, having intersections is not something that's too desirable. We'll want to offset these curves so that when we add the pipe, it's not intersecting with the thing that the pipes will be sitting on. So in order to do that, what we can do is take the curves that we have. We can divide the curves into some points, and using those points, we can look at the mesh itself, find the closest point on that mesh. Using that point, it'll give us the normal or the kind of the vector pointing straight off of the mesh, and use that vector as a movement to move the curves away from the mesh. And the reason we do that versus just using a scale component, because you could scale this up by a factor of 2 and it'll get away from the mesh. But since this mesh is concave in some places and convex in other places, if we just do a simple uniform scale, then some of the curve is going to intersect and some might be far away. So it's not really a good method for a more complex mesh like this that has a multitude degree of curvature to it. So in order to move these curves away, as I said, the first thing we'll have to do is divide the curves into points. So there's a lot of ways to do it. The simplest is just dividing the curve. Where's the simple one? You just divide the curve into equal length segments. So this will take every single line and with a number, say 10 or 20, it'll divide the curve into 10 or 20 points. So yeah, if we plug the curve into that, you can see that the curves now are populated by these lines. So 10 points on each line might work, might not. I'm going to go a little bit denser just so we have more points of contact to move these curves away. So I'm just going to use a value of 20 in a panel. You could stick with 10. Just depends on the detail of movement away from the mesh that we want to see. So the higher number, usually the better. But if you get too high, you might have too many points corrupting the line there. So I'm just going to stick with 20. So we'll also need to learn a little bit about the mesh that we have in front of us. So as I said, with the points from the curve, we can find the normals on the mesh that'll give us the vector to move the curves away from the mesh. And this will move it. You know, if we have a circle with a curve around it, we could easily take the center point and move everything away. But in our case, if we have something complex like this and a curve going around it, we can find, say, the normal vector here is going to be a lot different than the normal vector this way. Same as this one will go down. So if we use that, we can move the curve pretty intelligently away from the mesh in a variety of different vectors at the same time. So in order to learn about the mesh itself and find those normals, there's a really nice component called deconstruct mesh. So this one right here, you can deconstruct a lot of different things in Grasshopper. So if you have a B-rep, you can deconstruct that. If you have a bounding box, you can deconstruct it. You can deconstruct vectors, forces, and things like that. But one of the simplest ones is the deconstruct mesh here, and this one is super helpful. So what we'll need is this original mesh component. We could just duplicate it and grab the mesh and bring that over to the component we just added. You could also just connect the original mesh component with a line to deconstruct. But since that's so far away, I'll just bring the mesh over to keep the canvas looking a little bit cleaner.
Quick question real quick.
Yep.
My divide curve panel says that it's currently inactive. Or you can go, it's like a dark gray, the previous one.
Like this.
Yeah.
You could try right clicking and seeing if it's just not enabled. And hit that again. Did that work?
So, yeah.
Okay. Cool. Yeah, so now that we've deconstructed the mesh, you'll see the most visual thing that changed is we have the points on the mesh. So if you know anything about like digital modeling, meshes are made up of tiny triangles to construct like the facets of the mesh. And each of those triangles has 3 vertices. And we're seeing here all those vertices that make up the triangles itself. So that's the visual thing. We also have the faces, the colors of the mesh, which in this case, there's none. And also the normals that correspond to the points in the faces. So the vertices and the normals are the most important things here that we'll be using to learn a little bit about the mesh itself. So the next step, we had done this last class too with the attractor point, is using a closest point component. We can learn what points on the mesh are closest to the points in the system, the shortest walk system that we created earlier. So with the closest point component, and it should be the singular one, there's a closest points with an S as well, but we use the singular closest point. And with this one, plugging in the points from the divide curve, the closest point is asking for the point to search from, which is P, and also the cloud of points to be searching, which is the C input. So we know what points that we want to search from, and we know what points we want to find. So if we plug in the points we want to search from into P, as well as the points we want to search, which is the mesh itself, into C, this will do a simple calculation for us and find the points on the mesh that are closest to the inputs that we have. So this probably doesn't look visually too much different. The points will change slightly. But the important thing here is it's giving us the index of the points on our base mesh. And the reason why that's pretty useful is because the index of all the outputs here are the same. So the first point in this list is the first normal in this list and so forth. So if we have the index of all the closest points on the mesh, we also have the index of all the normals on the mesh. And then we can use those normals corresponding to the points from the line to move the curves with that normal value.
Is mesh normal the time?
So yeah, technically the normal itself is going to be in the middle of all the faces
Okay.
of it,
Mhm.
but it's not going to be too different because the point of the vertice is pretty close to the midpoint of the mesh face, so it's not a huge difference. So this will, yeah, it'll still work just fine, but yeah, I believe that's how it works. Okay, so since we have that index from the closest point, and we also have the normals from the deconstruct mesh, we can use the same component we used earlier, which is the list item. And the list item, in addition to at its basic form, selecting the first item in a list, it can also select every item that corresponds to an index value. So with this index, by default, it has the number of 0, but we can add as many indexes as we want to this list here. So if we take our indexes from the closest point into the list item, we can add all of those indexes here, and then taking the normals from the deconstruct mesh into the list, we can select those normals based on the points on the mesh. So we have that normal value, which is the vector off the mesh. So with that, we should have everything we need to now move these curves. We have the direction and we have the points to move. So we'll just use a move component. And there are a couple move components, but the one we want is the one that moves it along a vector, since we have those vectors now. So the inputs for this are a base geometry, in our case a point, and then a translation vector. We have those vectors. So from the list item, we have all those vectors, so we can plug those into the vector to move. And we also have the points from the divide curve from earlier that we can plug into the move, and we'll see that the points are now moving away from the mesh. And as I explained earlier, the points over here move to the right, and the points up on the head are moving away to the left. So they're moving based on the normal values of the mesh. And right now, you'll notice they all just moved, but how far did they move? It's not really explained. So one thing that comes with Grasshopper by default that's super nice is when we're working with vectors, we can control not just the position of the vector itself, which we found from the mesh, we can also control the length of the vector with this component called amplitude. So I'll grab that in, and since a vector is just a value, we could multiply the vector to change the distance or divide the vector to make it shorter. But that's not always the smartest way to do it. The amplitude itself will tell us exactly how long we want each vector to be. So I'll put that right in between the vectors and the move here. And before we move the points, we can use the amplitude to define how far we want to move them. So I'm going to just download it, make it easier. So yeah, with V is the vector, as it says, and then A will be the amplitude, or basically the length that we want to move. So again, we can use a slider here. I'll just use, again, a decimal up to 1. You can use whatever number you want based on how far you want to move the points away. but I'm not moving them too far. So if we plug that decimal into amplitude, it'll give us a new set of vectors that have the same direction, but now they have a different length, a new length than before. So if we plug that value again into move, you can see that at a very small amplitude, the points are basically on the mesh, but as I move it away, the points will all respond to that length value and move away based on the normal of the mesh. Not smart. Okay, that should be working for everyone. Let me know if it's not. Okay, that's probably fine. Hopefully that's fine on Zoom too. But my computer is gonna die, so I'm gonna plug it in somewhere. Let me just see. Okay, so now that we've moved the points, yeah, so I bring up a panel here just to look at the data again, and we can see that we have some branches like 8, 9, and 10 that have nothing in them, which the next step would be to create lines again based on these points. So we had the curves to begin with. We use the points to move them away from the mesh, and we'll again want to create the lines based on these points. So the easiest way to do that, to create a smooth curve, is to use the interpolate component, which will take a set of vertices and make a smooth line connecting all those vertices together. The only thing that I foresee, because I've already built this, is we have a couple branches here that have nothing in them. So if I were to plug the points in, it'll give me this error saying there's not enough points for a curve. That is because a branch like number 8 doesn't have any points, so you can't make the curve. So it's going to fail on us. It'll still make some lines, but just to show that there's a possibility of this happening, we can use the same thing we've been using a couple other times in this workflow, which is the clean tree. And what this one can do, as I said, is it removes anything like nulls or empties or invalids. But we will want to make sure that we set all of these options to true so that it is removing nulls, invalids, and empties. And if we've done that, you can see that now the list has no empty branches in it. So just make sure all these are set to true, and that should be working. Yeah, so there's a couple ways to do it. The easiest one would be to use a component called Boolean toggle. And you can double click this and set it to true. And then you could come in here and just connect everything there and it'll all be true. That's the easiest way to do it. The way I did it, which is a separate way, which isn't the most visually consistent way to do it, is if you right click on any input, it has options here like flattening, grafting, which we've been using quite often. But in this case, since it's a Boolean input, we also have these options here, like you could come in and set it to true and false, but then it wouldn't be too apparent what it's set to because I right clicked and went in. So using a component like this is just a good way on the canvas to see what you're doing. So I'll leave it like that. But now if we go from clean tree, plug this into interpolate, we'll get a very clean component here with no errors to it. Okay, so now we should have these curves that have been moved away from the mesh. And we can move them away with the slider to control their offset. And at this point, we're able to add the pipes to all these curves. And those pipes should no longer be intersecting with the mesh because we have this gap in between. So the next component I wanted to go over was Dendro. And Dendro is super nice. It's a voxel based plugin. So what it does is it works in a data structure called voxels, which is basically like a 3D pixel. And this allows us to do some complex things a lot simply, more simple. So the reason why this plugin is quite powerful is it has these Boolean intersection commands like difference, intersection, and union. Usually, we do have those same commands like Boolean, union, intersection, and difference with Grasshopper as it comes, but a lot of these commands are not the most stable in Grasshopper. So using Dendro with a voxel-based system is a lot more stable. So this is a nice way to do Booleans with complex meshes and things. We can also get curves quite easily as well in this, so the pipe is not as complex. So in this case, we have all these settings up here to convert different data types into the voxel system. So the one I pulled out was curve to volume. We also have a mesh to volume or a point to volume. But in this case, since we have a curve, we can convert that into a voxel-based system. So with Dendro, most of the time I use it to convert from something in Grasshopper like a curve into a Dendro language as a volume. We'll do some operations on it, and then we'll convert it back into something that Grasshopper can read like a mesh. So this system is kind of self-contained. We'll convert it into a volume and then convert it back to a mesh at the very end. So with this curve to volume, it has some 3 inputs here, and all these are pretty important. So the first one, curve, pretty basic. We have that curve, so we can just plug those in there. It's also asking for a radius value and a settings value. So the first one I'll touch on is the settings. So whenever you have a component in Dendro, it needs a settings to be able to compute anything. And the settings, if I grab that, is basically telling Dendro the size of the 3D pixel that makes up the shape. So that's the first setting here, which is the only one I'll ever touch with the settings, is the S up top, and that's the voxel size. So the higher the voxel, the less defined any piece of geometry is going to be. So the resolution is a lot lower. The smaller you make the voxel, so it'll have a lot more pixels making up the shape, you'll have a much higher resolution geometry coming out. But also, if you have a smaller number, your computer will take a lot longer to generate those voxels. Then if you had a higher number, it might take a second. A super low number might take 10 minutes or something. So you have to be careful of what numbers you set here. So what I usually do is create a slider from 0.01 up to say 5 or something, a higher bound. And in doing a slider like this, before I plug it in, I always move it up to the higher number because this will compute the quickest. And then we can iteratively go smaller until we get to a high detail mesh right there. So I'll take this setting and just plug it into the S. This is the only input I ever use on the settings. So with that number plugged in, the settings are defined, and we can move that into S here. So last thing is just the radius. This can be whatever number you want. I'm just going to make, again, a slider from 0.01 to 5 and use this as my radius. And just plug that into the radius there. You'll see if you do this, and if both numbers are the same, we'll get a little error that says the radius must be at least 33% smaller than the voxel size. That just makes sure there's enough voxels to actually show anything. So all you have to do for this is since the radius has to be 33% larger, I'll just move this voxel size number down until we get something showing up in the scene. So the radius is still super huge. So I'll move this down, I'll move both sliders until I get to something. That looks like a pipe of a thickness that I think is acceptable. And this one doesn't seem to be intersecting with the mesh, so it's a good size right there. But these numbers might be different for you based on how you have your scene set up. So is that working for everyone? You're seeing some pipes? Yeah, so if they're still just lines, you might have to move the voxel size slider down.
Oh,
And so you see voxel showing up.
oh, got it.
Yep. Yeah, so if you turn the radius down as well, it should just kind of doesn't see the bob slider. So the bob slider that I have is going like the detail level, and the top one will be the radius of those heights. But if you go to lower, we'll get that 32% error again. We'll just have to move the settings value down. Yep. And they should come back, yeah.
Yes, so getting an area with the boxes. What's the area? So, you have over, move away at all. You have over the same. Oh, you're in. Yeah. Did not see. Well, the box beside him might be the cool. I think it was like taxing on the system on the computer. That's why it's giving you that issue. So I guess for yours, I might go back a little bit, maybe to where we had that. Yeah, we'll go back. Well, another the same issue that we had earlier. The original input was problems there. Yeah. On that like slider. There, you just change that a little bit, see if something good happens. Yeah, we kind of slow, so I just do it and set it and go check to see if that. Stuff we want. So, I mean, I have seen this issue before. I'll send you a way to fix it.
Sometimes the curve component just fails, but there's a way to use the point to volume component to just make a curve the same way. What's this? Okay, so this one, the one I just put in the Discord chat, will make a curve from points. So you'll basically just plug in your curve to the thing I gave you, and it should give you a curve. It's a few more components than just one. It's like 10 or something, so I didn't do it here, but copy and paste that in and see if it works for you. Okay, so now that we have the pipe here, we'll notice that since it's still grafted in a larger list, if we hover over V, there's still a lot of branches here, which means there's a lot of different pipes. What I want to do is I want to make this one single mesh, so we can make it a lot smoother. So one way to do that is to flatten them all down. So we have a single list. And then we can use this volume union component. And this is kind of the power of Dendro, is being able to do unions super quickly. So if we union everything together, we get this one very consistent volume that has super smooth intersections. There's no like flipping errors with the mesh union, even though we unioned 35 things at the same time. So we got a super clean result from that. And if we tried this with the original union from the intersection tab, I can assure you it will not be as clean as this. So now that we have it as a single pipe wrapping around the mesh, we just want to convert it back to a mesh so we can use it in Grasshopper. So to do that, there's another component up in convert where we can convert the volume back to a mesh itself. So we put curves in and we're getting a mesh out. We can't really use volumes with anything else except for Dendro components. So you get that volume to mesh component right there. Again, this one needs the volume and settings, so we can plug the volume in. But it'll still give us an error. We also need settings again for this one to come out. We don't need to add anything to the inputs. We can just plug this settings in and it'll give us a mesh coming out. So that should be working. If it's not, I have questions on that.
Fine, but it is nothing more. Yeah, it's something changed for the source walk review. Now I'm having the same problem we had earlier, where it's not. It's whatever that same message was. And all the changes I made aren't doing anything. So I tried adjusting the values, putting in the duplicate points. It's stuck there.
Those that were very unknown.
I thought everything should be fine at this point.
And you said the emptiness true on that. So the top two should be true, but the you try to change all that again.
Yeah, I've not changed it many times since that. So.
You go down to the
I just keep like.
Yeah. We don't have any issues with testing. Yeah, I'll look at it later and see if I can find the other issues, fixing some things. Oh, okay, yeah, so, in Discord, I added, a file to the file chain. Oh, you have that? Okay, it's still giving you. If you cloud, this is better. And you, there are here. See here. We able to look. So I. Oh, yeah, went down to the files. Oh, it's trying to. Yeah. Okay, so the other Rhino. Well, you should be able to copy and paste it over. Oh. Okay, I think that might be an issue with the installing the plugin itself, if it's unable to load the DLL. Yeah, I would go back to the file that you downloaded. Yeah, is that that's what you downloaded? And under libraries. So did you put both of those? That's not good. Yeah, they should both be in the components folder in Grasshopper, and, yeah, well, that might be the same issue you're going to with the error is the LL issue. Yeah, so if you just put in, you have to restart Grasshopper and Rhino to see the change take place. So make sure you save Rhino and Grasshopper as well. Okay, anyone else? Any issues with the Dendro? Because yeah, one last, I know we're at 7. I had one last component to finish this off. For the people that have it working somewhat. And this will be on YouTube later, but with the pufferfish component is the last one I wanted to look at, pufferfish. And that is a component where you can easily do symmetry with a mesh. So right now we have a very unsymmetric pattern, which you might like, but with pufferfish, there's a command called mirror cut mesh, which is super powerful and has also a lot of inputs. And what this one can do is take any mesh and cut it down a plane, mirror it on that plane, and then combine the mesh back together, so you get a very symmetric model. So in this case, there's only a couple inputs that we need. It's asking for the input mesh to cut, the mirror plane to mirror it around. So we have that mesh to cut, so we can plug that in. It's also asking for the mirror plane, and since the input mesh that I gave you is right on the origin, we can just use the input plane
of YZ. And this will be a plane that perfectly bisects the model. And combining those together, we can see that we now have a symmetrical output of the mesh. So it's a little bit more organized on the mesh that we have here. Another thing we can do, since the mesh itself has some, I would say, kind of errors in where it connects, is there's a input at the bottom of this mirror mesh cut called bulge. It comes in at a value of -0.5. Not sure why, but if we grab a slider just with 0, we can change this value of -0.5 to 0. And then we'll have a much cleaner intersection between the two halves of the mesh there. So now that should be the smoothest the mesh can get. So with that, that's pretty much the workflow. The last thing I wanted to show was just previewing things in different colors in Grasshopper, so you don't always have the red and the green. But if you want to see like a solid gray model or something, so you can visualize it better. In the display tab at the top here, there's a section called preview. And in this section, we can set up a custom preview to give our models custom colors in Rhino. So we can have more colors than just red and green. You can do any color in the spectrum and have a lot of different colors in the scene. But I'm going to grab 2 of those custom previews, one for the base mesh and then one for the kind of the pipe model that we just created. So if we plug the output of the mirror mesh cut, which is the M here, which is the resulting meshes, into one of the previews, you'll see that by default it shows up pink. But we can easily change this color with a component called color swatch in Grasshopper. And with this one, if we double click on the color, we have a whole RGB or HSV slider with the hue, saturation, and the value. So we can set this to any color we want. And just hit accept, and plugging that into the material down here, display material, we can get this coming up as a solid teal model. So we can visualize multiple different things at the same time. And we can do the same thing for the base mesh as well. And just give that a different color. So now we can see just how you can quickly create different colors in Grasshopper. If you don't like the original selections, or if you want to see compare like 10 different things with 10 different colors, you can do that with this. So yeah, that's the workflow for this. And right now I started with a very small number, but we can move these numbers up that we had at the beginning here. So if we want to add more connection lines to make the kind of the garment more complex, we can add different numbers here. Can even go up to 400. And we can just make this pattern around the body more and more complex with the higher numbers we add. We could also make or add more points to the voronoi if we wanted a more intricate setting, because remember, these lines are only following the voronoi intersection curves at the very beginning. So changing this will change everything else as well. But yeah, that's the workflow for that. You can do this on any kind of input mesh. So if you change the input mesh, it'll change the pattern. If you change the voronoi count, it'll change the pattern. If you change the number of random reduction that you do, we can also add more curves or less curves. Yep.
So I changed color, but like only partially, some of the types have changed colors.
Yeah, so you might have this one still previewed on, or one from earlier in the script. So I previewed off everything else except for the custom preview. And let me know if that fixes it.
Yeah.
Okay, cool. Yeah, that might get in the way sometimes. So yeah, that's it for this. For next class, the only thing that I wanted from today is with whatever output you got, if you just take a screenshot of that and put that in the Discord with whatever colors or shapes that you want. That's all I'm looking for out of today's class. And then next class, I believe, is the 14th. So that's Valentine's Day. I was just going to cancel class because why not? So have fun. I'll see you in 2 weeks. Yeah.
I think I found the problem for mine. I don't have to change it though.
Okay.
So this thing here that I'm assuming is the stuff here. However, adjusting the value and stuff, the point doesn't go.
So if you put, when you put in the YZ lane, I think that's what that is. So you are YZ lane, but no, yeah. But it should be, I mean, if you still didn't follow along, it should be at the very end of the script. Yeah, so that and YZ, if you just leave that off. You know, yeah. Well, that one, yeah, I mean, there should be like at least one section. Lines. Yeah, that one. Yeah, so, like, if we zoom into the head up there. Yeah, like, I don't see why it could find any, actually, kind of like, there should be a better. Sure, but like, it did work at one.
Yeah, it did. We're making that it. Something must change. I must have instead of us.
What's the error?
Yeah.
Oh, that's what. Not completely true. I mean, if you save this and send it, it takes one time. Yeah, I was just trying to. Oh, yeah, so That's the interpretation. Yeah, so if you put this here. Put this there. And then go ahead and find it. Yeah, so that's the same problem they were having. This, it should work, but if you want to see what you like when you talk about. So I just go back to the Dendro that you downloaded to make sure everything is delivered, look at all the folders. Yeah. Roll over and you start. It should work. Okay. Yeah, that's a good point. I'll look at that. Okay, I sometimes then. General. I'll just. Make sure everyone else.
Why do you want I don't know.
Yeah. Oh.
Yeah. So you type in a number.
I named it. Yeah, so if you right click on it. So there's a little blank spot, that's actually a box. It just doesn't show up. Okay, then whatever. You just disabled it with the flash. I just named this like a keep track of it. The only reason I did this is because the base rectangle is so far to the left, and then it's so far to the right, that you could just drag that wire all the way over where you want it. Yeah, the base rectangle, I guess it's like that. So I was taking the output from R and sticking it into somewhere over there. But an easier way is like just shove it into that, which does nothing. It just like pulls it, and then you can slowly drag it up to the end of it.
So after I'll be able to jump into you instead. Okay.
I mean, I'm just building, and then, so this is like the actual with the building, which, yeah, this is right there. This would just take it into the, and off the ground plane. So, but yeah, the relay is just like an organization of tools. You don't need it, but it has sometimes with a lot of wires, to make it look really complex. You can just use the spaghetti out of the way.
Mine didn't like properly into my name. Did you learn to do this?
Yeah, I did all.
Okay, so yeah, this is where
Yeah.
I'm at, and then with the really. Okay. That was all.
Okay, yeah, so there should be like 7 different things. Right, so it should be like 70. So it, I just didn't move everything. Did you unzip it? Right now it's this one. So I'm assuming you'll block it. So now, yeah, I can grab it all. And then. So it is.
But it's
Pull that grasshopper again.
So it looks like we just have average. So this is the only one we have.
so it's like,
You don't have, you can just go back to your other file and just delete it.
Make sure you also move that. Make sure you move that green one to the components folder as well. Then you should, once you restart. Is it the same error? Did you restart everything? Right. You're running this in Rhino format. That might be the issue if nothing else is causing an issue. It might be that it's in the Mac operating system. A lot of plugins for Grasshopper are only written for Windows operating. So there's some, like the pufferfish component works on Mac no problem. Kangaroo will work on Mac no problem. But most of the other ones are written by people that like go to a lot of these schools, like they're not a massive developer, so they don't write for Mac. So yeah, it looks like you have everything fine in here. So I would assume that that is probably the issue at this point. If everything is unblocked, which I actually don't have to block that. Yeah, so I put in the Discord last week, I think someone asked the same question. There's 3 different softwares I put in there that allow you to either partition from your hard drive to handle the Windows operating system. Yeah. Or it's a software that you just open it up and it has the Windows thing on it. Yeah. Yeah, so you could like run a virtual copy of Windows in Mac and then run Rhino in there. And then you shouldn't have a problem with any plugin ever. They're all good for Windows. I would assume that's the issue. Yeah. Sure, because it looks like it's fine, but I know that one. Yeah. Wait, so yeah, in the Discord, there's a section called recordings, and I post everything in there. So last class, whatever day that was, like the 20 something of January should be in there. Let me check. Yeah, so February 1st, there's one in the recordings from that time, so you could watch that if you want. Yeah.